So we're going to be talking about compliance-ready virtual infrastructure and how to address PCI security standards for virtualized deployments. I'll be talking first, and then Tom will come on stage to do the second part of the presentation. So just quick show of hands. How many people out there are actually security people or compliance people? Okay, good amount. All right, so here's the agenda that we're going to go over. I'm going to just kind of present some more background type of material, talking about how virtualization affects security and compliance. Then I'm going to be talking a little bit about virtualization security. What are some of the foundations there? Because that's obviously, being secure is obviously the foundation for being compliant. And then Tom will come on stage and talk about these other topics here, current limitations with the current DSS, and then some examples of how to deploy something to meet PCI requirements. So when it comes to virtualization and security, customers will often ask, how does virtualization impact security, data center security? And the approach you really should take is to look at what you do in the physical world, the standard world, and then kind of take those same principles and apply them to the virtual world. So if you look at the different kinds of controls that exist out there to address both security and compliance, you could look at kind of four broad areas. I mean, there's probably other ways to slice and dice it, but here's some four broad areas you can look at. Network controls, change controls and configuration management, access controls and management, and then vulnerability management. So I'll talk about each of these in turn. Network and interface controls. Basically, anytime you have an interface into a system, it represents a possible point of attack. And any vulnerabilities that might exist, that's where you could possibly take advantage of them. So that's the issue here. And I say network and interface controls because when it comes to a virtual machine, I could kind of you can kind of describe it as having two main interfaces. One is the virtual machine's network, which is kind of the same thing in the physical world, how you get in through the regular network interface. But also, with a virtual machine, usually you have this concept of it's running on a hypervisor, and there's communication between the host and the hypervisor that occurs, between the virtual machine and the hypervisor. And so that also represents another point of basically interface that you have to worry about securing. So I would say that's the one kind of main difference that you have to think about when it comes to virtual machines. And so the way you address this is, again, the kind of things that you think of doing typically in the physical world, but doing them in the virtual world. Restricting or disabling unused or unnecessary interfaces or services. So basically turning off things that you're not using, locking things down, locking down interfaces that you are using, but maybe restricting them to only exactly what you need. And then in the virtualization world, something else that's a bit unique is this concept of isolating your non-production networks. With a typical physical workload, you have one interface into a physical box, and that's where a lot of the traffic flows. That's where all your traffic flows. But in the virtual world, you actually have deployed your vSphere layer or your virtualization layer on your physical hosts, and then on top of that, you have your virtual machines running. And the networks that you use to manage your virtualization hosts, the actual virtualization layer, do not need at all to be in any way exposed to your virtual machine production networks. So that's kind of another unique thing about virtualization. And so that's something that the idea is using the same principles that you would use in the physical world, but applying them differently in the virtual world. So just a quick glance at some of the technologies that exist out there, ways to provide these network and interface controls. Next piece here is change control and configuration management. So the broad issue is incorrect configurations can lead to poor security posture or exposed interfaces. So the basic idea is that number one, you want to make sure that you can assess the state of your environment, assess the state of all your hosts, how they're configured, make sure that they're they are configured in the proper way. Number two, you want to make sure that any change that occurs happens in a kind of well-defined manner. You don't want to end up in a situation where something got reconfigured or misconfigured and you don't know how it happened. And so the general solutions you want to look at are the ones that will do the following. So, using predefined embedded configurations. That's obviously one of the best ways to actually go about making sure that you have a well-defined, well-configured system from the beginning. So examples of that, using VM templates instead of trying to build VMs from scratch all the time. Using the VMware host profiles feature where you can kind of stamp out the configuration of your host and instead of having to configure it manually every time. Of course, you can use scripting to achieve a lot of the same effect. I guess how you do it is sort of secondary to the important point that you should be having well-defined pre-vetted configurations. Having enforceable and repeatable procedures. This is something that's a little, that's hard to kind of give you prescriptive guidance on. You can't, it's kind of something that you have to go in your company and set up policies where you have ways that you kind of, when things happen, you can do it in a manner that can be tracked. Now, there's lots of tools out there that can help you with this. And in particular, I'll just point out like vCenter Orchestrator is a great tool where you can actually build workflows and have them exactly defined to do what you want to do. And it's actually a great tool for the purpose of compliance because it can really lock down what anybody can do. So most of your admins, all they can do is run predefined workflows. And so you automatically get this notion of having a repeatable procedure. And then monitoring and tracking all important system changes. This is the point of being able to know when things happen. And vCenter itself, we have features like event-based alarms and things like that can help you with this. The vCenter Configuration Manager is another product that we recently acquired, the former ConfigureSoft product that does this kind of thing as well. But again, how you do it is kind of secondary to the fact that you want to be able to do things that address this particular concern. Access controls and management. Now, as you know, you don't want to grant excessive privileges to users because then they can do harm, even if it's not intentional. Sometimes it is intentional. That's where the insider threat comes into play. And again, with virtualization, you have this different layer, this virtualization layer that you need to worry about to control the access controls at that point, not just in your guests. And so with a product like vSphere, you have the whole ability to do centralized authentication using Active Directory, using roles and privileges to lock down what people can do, restrict what they can do. And then finally, you want to have that audit trail of what people are doing. So both vCenter, Server, and ESX have the concept of recording events. So vCenter has the events table, ESX and ESXi have the log files. So these are things that you'd be doing additionally in the virtual world on top of what you already do in the physical world with your production servers. And this piece here around vulnerability management. No matter what you do as a customer or a user of a product, you can do a lot for securing your environment. But if there is some vulnerability in the code, then there's really nothing you can do about that. That's something that we as a vendor have to fix. And so staying up to date on patches is one of the most important things you can be doing. And as you're probably aware, we have a lot of ways to do patching inside in our ESX layer. So keeping track of the vulnerabilities at the virtualization layer, patches at the virtualization layer, is pretty important. So a tool like Update Manager can help you with that. The other point here about VMs is that when you're running virtual, you might have some VM that's gone offline, and it might have fallen out of your normal patching mechanism. It won't get the updates. Some update tool won't know that it's there. Or not only just patches, but things like antivirus signatures. So that's a case where you have to be aware of the fact that if you do have offline VMs that you might have suspended or done something with, maybe you used to have a snapshot and you want to roll back to it, you have to be aware of that and make sure you include those in your processes for updating patches and antivirus and things like that. Okay, so when it comes to virtualization security, the foundation really is a secure deployment. And for this purpose, VMware has been releasing hardening guidelines for the past couple of years. So I've been working on most of them, the ones that have come out. Most recent one has been vSphere 4.0, the vSphere 4.0 hardening guide. And it's really something that's definitely worth checking out. It presents a rather exhaustive list of more than 100 recommendations or guidelines for how to securely deploy vSphere 4.0. And this is really the foundation. If you're going to have any kind of compliance system, all compliance requirements will say, you follow vendor hardening guidelines for doing deployment. So we have the vSphere 4.0 hardening guide. We're also working on other guidelines for other products. So the recently announced vCloud Director, we hope to have guidance around that, as well as with VMware View. So this is something that there's a whole, you can do a whole kind of this whole other session just on the the topic of hardening. But this is one of the key foundations of having a compliant environment. The second piece here is around making sure that your virtual machines are secure. Now, this is an area where you should be doing what you're doing in the virtual world that you do in the physical world. So at the host level, doing things like patch management, as I mentioned, antivirus, staying up to date on that. At the network layer, providing various kinds of network protections like IDS and IPS. And then at the edge, providing firewall type of security. Just because you virtualize, you shouldn't not do any of that. Those are things that you should be doing in the virtual world. Now, having said that, there are a new generation of tools out there that can help you provide VM protections in a better way. There's you probably are aware vShield is a suite of tools that we just recently announced. So that's a set of tools that address all these areas: host, antivirus, network, and edge services. Of course, there's a whole other ecosystem of partners out there that will also provide similar kinds of tools. You have your Altor, Reflex, companies like that. But the important point is that you should be looking at securing your virtual machines and providing the same types of protection as you would for physical servers, even though it might be in a different way. The last thing I want to talk about here is this concept of virtual trust zones. So in most cases, when it comes to compliance, this is kind of a concept that applies very much to compliance. The concept of a trust zone, where you have VMs or servers that are on the same network segment, and they're at the same level of trust. In other words, you put them in the same trust zone because the communication between them flows rather freely. Going between trust zones, that's when you want to have a harder boundary. Maybe you have a firewall that has very few ports open. So when it comes to that's really this concept of doing segmentation at the network layer. Now, when you virtualize, as you know, there's a virtual network that's sitting there. You can actually do the same kind of segmentation at the virtual network layer, even for hosts that are all running on the same host. So you can have one physical host or one cluster running 3 different LAN segments, for example, 3 different VLANs. And the VMs themselves don't actually communicate with each other except through the network, and you can impose network controls there. Now, as I mentioned, with a new generation of security tools that are out there, a lot of these tools are becoming virtualized. So you can have a virtual firewall, virtual IDS, IPS. So that's essentially kind of taking the same technology that exists in physical appliances and making them virtual. So it's not necessarily any different. I mean, you're taking the same concepts, same technology. A lot of times it's the same code. It's just compiled for x86 architecture, and you run it in a virtual machine. So this is that concept of virtual trust zones. And when it comes to compliance, a lot of compliance is about doing network segmentation of sensitive data away from everything else. And so one of the key challenges here is to say, okay, I'm going to do that in a virtual manner. You're going to have to prove that what you've done, number one, is done actually in the proper manner, properly secured. And number two, that it can satisfy all these other requirements that a typical compliance standard would have. such as change control, access controls, and things like that. So having laid the foundation there, I'm going to have Tom come up and go on, give the rest of the presentation.
Thanks, Charlie. So as you can tell from my lack of VM shirt, I'm an assessor with Coalfire. And so for those of you guys that are not deep in kind of the PCI space, payment card space, the PCI has a set of qualified security assessors can do assessments. The organization I work for, we're one of the largest there. We specialize in applications and a lot of the service providers that we have out there. So the publicly listed ones are Oracle and some other ones that we're working with Microsoft and some other ones. So we're in a unique situation where we're going through and evaluating virtual compliance and what's going on. The first thing I want to kind of start with is the difference between compliance and security. So how many people here are actually auditors, internal audit or external audit? So this is even worse than Monday. So that's kind of one of the issues is that when you kind of look at auditors, some of the auditors kind of have a experience. I didn't ever want to be an auditor. I didn't think about that before when I was in the Navy. But one of the things from an auditor is that our job is to basically, depends on kind of your experience, but a lot of people are used to working with auditors that kind of go through checklists, write a report. They spend a lot of time doing very little and implementing something out. And on the security side, we're trying to figure out what they're looking for so that we can figure out how to make them happy and what's really required. And the reason why that's a big difference is because people don't equate compliance and security are not exactly the same. And a lot of people, if you're on the security side, which I was before I really spent a lot of time auditing, you don't have that perspective of what an auditor is doing. So one of the things one thing I was thinking about on my way here was a good analogy for security is like our home security. So when we think about it, everyone hopefully lives in a house or apartment that they think is secure. Now, if you were to ask everyone here, everyone has different levels of what's secure based on their house. You've got different locks, different things on your windows. I doubt anyone here has a house that's so secure that you guarantee that no one can break into it, right? You put some reasonable controls in place to make sure that you feel safe and they're there. And that's kind of similar to compliance. What we're doing is what auditors and assessors are doing is making sure that security and the controls that are in place are reasonable and are based off of what kind of the industry standards are. And so when you look at all the different regulations out there, there's HIPAA for healthcare, which has kind of emerged now with some of the high-tech regulations. There's Gramm-Leach-Bliley for all the banking. The SEC has their own requirements. NERC-CIP has their ones for utilities. Federal deals with certification and accreditation. And then PCI is one. Well, PCI has gotten kind of one of the most attention, or the most attention in compliance because it is one of the most prescriptive. So when you look at like a NIST document, it doesn't tell you that you can't have FTP open on a firewall, but PCI will. And so even if you're not in the PCI space, it's important to kind of understand what's going on because PCI is driving what is reasonable and what's acceptable in a lot of the auditor and the auditor community. So it's important to know that when you're an assessor, we basically are going to be doing three different things. They're going to be confirming that controls are in place by doing observation, inquiry, and inspection of documentation. And so when you look at that, we cannot generally do just inquiry alone. So you normally can't just talk to an administrator, say, do you have a virtual firewall in place? Yes. Is it logging? Yes. Okay, check. You can't do that. You have to observe it, and then you have to have some sort of documentation. And the documentation is the area that a lot of the security community is lacking because they don't know really what's there. And to your credit, there isn't a lot of guidance out there. So when you actually read through the data security standard, it's over 2 years old. It's about 2 years old right now. The next version is going to be published. The word virtualization doesn't appear at all in the data security standard. The word virtual does, but just in respect of virtual private network. So as an auditor and assessor, you're looking at the PCI DSS. It really doesn't provide you guidance on how to assess virtualization. Technology is advancing very quickly, and you guys are stuck in saying, hey, we need to be PCI compliant, we need to do this, or I'm assessing an environment or working with a service provider that is PCI compliant. How do we do that? So what I'm going to cover here is a lot. I put a lot of verbiage up here on the PowerPoint, so if you want the deck, I can provide you the deck. We got our email addresses out here, so don't worry about taking notes because there's a lot on here. I'm going to go through kind of three general things. Is one, what are some of the common questions I see as an assessor in addressing requirements for PCI in a virtual environment? And then second, I'm going to run through some very basic architectures of what we see and how you should document this in a deployment. And then three, I'm going to run through all 12 areas of the data security standard very briefly to kind of let you know what are kind of the major areas that you should be looking for in a deployment. So the first question I'm asked is, Tom, why is PCI so hard for virtualization? Well, the first is that technology changes faster than the standard, and it always will. So if you're waiting around for the guidance from PCI or the guidance from any sort of audit or assessment community, you're never going to get it because they're never going to be able to provide it as quick as technology is changing. 2 is PCI applies to all systems in scope. And so segmentation is what defines scope. And the PCI DSS is vendor agnostic. So they don't say in a virtual environment, if you're using Orchestrator and you're rolling out this way, it will be compliant. So there's no such thing as a compliant product or a compliant solution. It's all how it's implemented and what the functionalities are. And most of the white papers, when you read out there, are based on security configurations or very specific to vendors. So when you read the ESX benchmark or when you read different benchmarks, they're around security, but they don't say specifically for PCI what's expected because they can't. Because they don't know your environment, they don't know how you store credit card data, so all they can do is provide some guidance and then allow you to work with that. So what is in scope? So that's kind of the next question I'm asked, which is, all right, PCI applies to everything in scope. What is in scope in a virtual environment? Well, if you look at PCI, the definition of what is in scope is all systems that store, process, or transmit credit card data. And if you're new to PCI, a lot of people mistakenly think that it just applies to storage. So they say, hey, if I got a web server, but I'm never actually storing anything, and I'm just transmitting it out, that web server is not in scope. Well, that's not true. If it's processing or if it's transmitting that data, then that server is in scope. So what's unique in a virtual environment that will be different from its physical counterpart? Well, I've broken it up into 3 different areas for you. So the first is storage. So in virtualization, data that used to reside only in memory, in volatile memory, has a chance of being written now to disk. And so things like encryption keys and stuff like that that are generally in memory that you don't really worry about, or applications that design and secure that in memory, could now get written to disk. So that's something that's unique that you have to make sure that you know when you're looking at what the risks that you're taking, like taking a dirty snapshot or what you're building, of where you guys are replicating that disk. Because if you take a snapshot and you move it to another system or you put it on a USB drive, those systems are all storing cardholder data. The integrity of data can also be altered. So what's different in the virtual environment is if you can break into Active Directory, if you can break into some other system, generally you can use those credentials to attack other systems, but you can't actually alter the state of those systems or delete all those logs without there being some sort of trail. Well, that could be unique in a virtual environment depending on how it's architectured. If you have access to the hypervisor, you basically have access to all of those systems, so the integrity of that data is very different. And then when you look at the SAN, can virtual images be altered while they're stored? So that's one, a unique risk that they have, that as VMware is going and deploying a bunch of different solutions, we say, well, you've built a hardened guideline. Once you have a server running, generally it's very difficult to alter that in the physical world. But in the virtual world, it's very easy to say, oh, wait, let's just replace it with this, and that new build could be different. And where you're pulling that build from, if someone has altered that, could now introduce a risk to your virtual environment. So those are some basic kind of unique risks in storage that we see. The other 2 areas for transmission and segmentation we'll kind of go into in the next slides. But when you look at that data that used to only be in one location, now can be logically transmitted. So when you look at transmission, as you're using vMotion or you're moving things around, data could be transmitted in areas that you're not used to in a physical environment. So those are some areas to think about. And same thing with segmentation. Charu covered a lot of it with VLANs and networks and all of that, but the segmentation is definitely different. So the other question I'm asked is, well, aren't firewalls required for segmentation? And when you look at it, when the DSS first came out, the data security standard, most assessors, basically qualified security assessors, relied on stateful packet firewalls as a way of doing segmentation. Now that has obviously evolved a lot, and there's been more adoption into VLANs and access controls with routers, and what is the definition of a firewall? And how is that different? When you look at antivirus, that versus whitelisting, what's the difference in some of those things? So PCI does allow, and if you see there that quote that I have there, PCI does allow for other technology. So PCI says you can segment, but you can segment using a firewall, but you can also do it with routers with strong access controls, and you can also do it with other technology. We recognize there's other technology out there that's acceptable for segmentation, and it's up to you as the assessor, the merchant, the service provider, to define what that segmentation is. So one of the things that's unique is how do these firewalls impact the flow of data in a virtual environment? And that's something that, particularly if people aren't used to working in virtual environments, or you have auditors that are used to just going off of checklists, they have a hard time interpreting this. And so the next one I talk about, and this is kind of one of the biggest areas that we see with a lot of kind of newer assessors, is, well, what about one function per server? So the reason why you are virtualizing is not so that you can have 100 different virtual physical boxes running right? You're trying to virtualize to save some hardware costs, to save with some other areas. And so if you're going to take 100 servers and virtualize them into a cluster, how do you do that? And does that still meet the one primary function per server? So at a high level, we would say yes. I mean, if you look at this quote, this is the area you can talk to, which is really, when you virtualize it, that still is, each virtual component is a component. It's a unique component. So you can have a virtual web server and a virtual database in two different locations, and that's totally acceptable because it's running on the same hardware. The hardware is really not what's important, right? It's the virtual layer and those controls that are in place. And you can see all the quotes that I had, they were mostly on PCI DSS section, page 6. Because page 6 is really what defines the scope and what are the system's components that are in scope. So if you haven't read it and you don't want to read through the 100 pages or so of the data security standard, at least read page 6 and use that for your discussion with your auditors and assessors on how you're going to be interpreting this requirement with what's coming out. And the last part I'm really going to talk about is documentation. So one of the things that assessors are always looking at is, all right, once you guys have it, you have to start documenting it early to understand what the segmentation is, how it's going to be deployed. And I'm going to go through a couple examples of some documents that we recommend people use. And if you want copies of these, I'm more than willing to share them. So we basically say assessors should be looking at 3 things. We start with input. So if we're assessing the security of data, that data has to originate from a location. So that's going to be the input. It's going to get processed somehow, and then there's going to be output. So what helps an assessor is to break down the way that you're documenting and the way that you're showing your diagram into input, process, and output. And that's not what normally happens. Normally we see a network architecture that is just a flat diagram that has a lot of data that maybe sometimes has arrows. And so one of the things that we recommend is doing something similar to this. So when you look at this deployment here, it's broken down into kind of 3 major sections. So this blue area I have is input. So in this organization, it's taking credit cards at a point-of-sale system, telephone, fax, and its website. Credit card data doesn't just exist in an organization. It has to come from somewhere. These are the 4 areas that it comes from with some brief, a brief description of what that is. So that helps us understand, okay, great, this is where data starts. This is a part that gets a little bit trickier, that obviously you have to rely on your assessor and make sure that they understand what all the processing is. But don't just jump to all the routers, the databases, and servers without first defining what the input is. And then last is going to be the output. So how does it go out? How does it go out to the bank, or to the processor, or whoever, the service provider that you're sharing it? Right? Organizations only take credit card data for a reason. They're doing something with it to take money. They have to process that out. So it's important to document it this way. And so we recommend that you guys are doing your cardholder data flow in this environment. Now, this still doesn't help you with the virtual environment, right? This is still a very high-level diagram of input, process, and output. So what should be in a document for virtualization? So you're saying we want to move forward. We want to document it. Why is it so hard? And so these 10 areas here are some areas where we're saying, well, these are why they're so difficult. Right? The system boundaries are not as clear. In a regular environment, you can say it's segmented by an ASA. Everything on the left is PCI. Everything on the right is not. But the boundaries are different. You rely on different components. You rely on access controls, VLANs, virtual switches, virtual firewalls. Those all need to be in the diagram somewhere, but it's hard to do that in a virtual environment. Right? It's not going to be part of your regular deployment. And some of the other things on here, I mean, you always have discussions with people saying, well, what about VM escape? What about some other areas? And so there's a lot of unique risks that hopefully I'll be addressing here that you guys can make sure that you're prepared and working with your assessor. But there's a lot of benefits there. And when you look at it, I was just listening this morning with some of the different acquisitions that are going through, right? The cloud, there's supposed to be a 50% increase in data moving to the cloud in the next year or two. Virtualization, I think you guys had another slide deck that said 100% of all Fortune 500 companies are using virtualization. So it will happen. It's going to keep moving on, and we're going to have to be working with these different regulations on how to do that. Because there are a lot of benefits for virtualization, and it will come. So when the important thing is really defining what a system boundary is in PCI. And so when we look at this, I picked a basic standard hardware deployment of a basic web server and a database. So in this example, someone just has a web server that's going out to the internet, going to go through, they're going to have a database. These are usually in 2 different areas, right? This is going to be in their DMZ. This is going to be on an internal network. And then they've got support systems. And so these are things like Active Directory, logging servers, that these all allow access control into these areas. So this is a pretty basic environment. It's easy for us to understand this. It's easier for us to understand this is in scope and this is in scope because these systems store, process, or transmit cardholder data. And these systems don't necessarily store, process, or transmit cardholder data, but they have controls that are probably going to be required by the assessor to say, well, how do you enforce password controls? How long do you store those data? Where are those syslogs sent to? So those are what we call supporting systems. So if you take that exact same environment and you move it to a virtual environment, you can see the complexity increases significantly, right? You end up having some of the virtual management structure environments, and then you also have what's running on the ESX, and if you're storing in a SAN, that's unique. So just by nature, taking a very simple environment and moving it to a more complicated environment gets more complicated. And if you're in this room and you're interested in virtualization, you're probably not looking at virtualizing 4 servers, right? You're probably here because you've got a large, complex environment. So you can imagine this kind of scales out. So here's one way that I suggest that you work with your assessors to document what would be happening in a virtual environment. So when we look at this, you take your existing physical environment and you put everything in the virtual environment. None of that changes. And so I kind of put a box around this because I said, look, everything here is going to be the same. The servers, the database, the log management. We're doing everything we're doing in the hard environment. We're doing it in the physical environment. We're moving to a virtual environment. It's going to be easier for the assessors to understand that. Then the second part is they say, well, what about the unique risk of virtualization? And you say, glad you asked. So these are some of the areas that you say, well, we have a separate environment for our DMZ where we get the update management server. There are a bunch of management components that are unique to virtualization. So you look at the vCenter console, update manager, all of those. So these are kind of the main six areas that I usually find in kind of more complicated environments where they're going to have some of these things, like a jump server, so that they don't want people having direct access to possibly break into the system. And then you want to be addressing kind of the physical devices here along with their SAN. So this is kind of a very basic way of showing kind of that segmentation for an assessor of, all right, these are the components, and here's how I'm going to protect them. This is the cardholder data environment, and these are management systems, and this is kind of the DMZ. So your focus is mostly going to be around these 2 areas here. I had some questions after the similar presentation on Monday on, well, do all these components have to be separate, and are they allowed to be virtualized, or can they get spread out? And so I'll talk to you guys about your unique situation, but at a high level, if the larger you are as an organization, I think the more expectation there is that these things are protected in their own management environment, because access to these components now could lead to access to the hypervisor level, which now can increase this. So the risk is different, and because of that risk, these areas should be controlled a little bit stronger. So one of the areas with documentation is how do you document that? So there's a lot of discussion right now. The new data security standard is going to get posted in October, and they're going to have what's called a SIG, a special interest group, which is going to be a supplement on virtualization. Unless the draft changes significantly, there probably isn't going to be the level of detail that you're looking at to really document. And one of the areas that are being discussed is if people are going to virtualize, we would like this to be documented in a compensating control. Well, one of the issues with that right now is if you look at the compensating control, it's very specific on how and prescriptive on how you need to be addressing it, and it really doesn't work for a virtual environment. So I suggest as you start documenting this based on kind of the next slides I have in kind of the way that I have it, and that allows you to kind of get ahead regardless of how the DSS gets published and regardless of what assessors you have, they're going to be looking at these same kind of components. So I'm going to go with the executive summary. If anyone's read a report on compliance, it's got an executive summary and then kind of 12 sections. And so I'm going to run through those really quick here and make sure that we have some time here for questions at the end. So the first risk for requirement is going to be in the executive summary, right? It's going to be very important that this document describes what virtualization is being used, how it's being deployed, where the cardholder data is, and what the organization has done to implement the unique risks in a virtual environment. So I've documented here, I kind of bulleted out 4 unique risks that should be in the executive summary if I'm reviewing one or if I'm working with a customer. And so the first one would be defining the CDE. It's very difficult to do that in a virtual environment, as we just said. The next one is, will this address mixed mode virtualization or multi-tenant virtualization or anything like that? It's very easy, or it's much easier if you just virtualize everything and you say everything that's virtualized is going to be PCI compliant, which means everything is logged to that level. Everything is configured to that level. It's easier to take that baby step and then segment that out than to try to have what we call mixed mode or multi-tenancy or anything like that. Also, if other technology is going to be used, they need to be described in detail. So if you're going to be replacing physical firewalls with virtual firewalls, and you're going to be using, instead of a regular, like with the old way with ConfigureSoft, if you're using the way that VM is doing with their virtual environment, you need to describe those in detail. And remember, there should be 3 diagrams. So when we look at it, you should have the data flow of the cardholder data environment that I showed, the input, process, output. you should have the logical diagram of the physical components so that physically you can see what that looks like with the routers and switches and where things are stored. And then that third one is the logical diagram of the virtual components. So do an assessment, kind of like I showed with that other diagram there. So you can see here, there's a bunch of different ways to address them. At a high level is document every system component. If your network's simple, try not to make it overly complicated. If this is your first step in moving towards PCI compliance or something like that, try to keep it as simple as possible. And then the other technology, this is probably one of the biggest mistakes when we go in for the first-time assessments. If you're going to rely on other technology, you have to define that in detail. You can't expect your assessor to know all the different technology, all the ways they're being deployed. And a lot of times, the last time that they assessed something, that technology wasn't there. So like when you look at some of the earlier versions of ESX, the logging wasn't there. PCI requires that you're able to log to a certain level of detail, and it was really designed for troubleshooting. So there's a lot of ways around that now. You can see that they continue to improve those processes, but it's important because your specific deployment and the types and versions that you're using are going to be different. So you want to document that as you can. So PCI requirement 1 deals with firewalls. And again, firewalls have historically been stateful packet firewalls. PCI went and updated their requirements to say, we want to be clear. PCI requirement 1 doesn't apply just to firewalls. It also applies to firewalls and routers. And sometimes it'll apply to switches depending on how they're used, like if they're used for VLANing. And based on that, remember that first slide I showed you said that segmentation uses firewalls, routers with strong access controls, or other technology. So where it's appropriate, don't just say, well, we have one firewall, it's a sonic wall or a checkpoint, and just describe that in detail. You're going to have to start defining what your virtual firewalls all are. If you have different modes of segmentation with access controls, those also need to be defined here as well. So you can see I've bulleted out kind of several different ways that I recommend that you guys can help address this in documentation. Number 2 is dealing with vendor default supplied passwords. And so this is another area that's difficult. So one of the unique risks in a virtualization is it's a very dynamic environment. Right? The number of servers running and the number of components running at any time may vary from minute to minute depending on the size of your organization. And so the way that those virtual components are provisioned and rolled out, updated, retired is very important. So I threw that in here in the vendor default systems because it's important that those systems and the way that you guys are doing that are well defined. And if you have a component that doesn't meet some of these requirements, some of the hardening and the default settings, then you need to understand how you're going to compensate for that as you move forward. So 3 is dealing with protecting stored cardholder data. And again, so this is any data in storage. And it's mostly requirement 3.2 and 3.3 and 3.4. And so when you look at it, credit card data must be rendered unreadable anywhere it's stored. And you can do that by doing encryption, hashing, tokenization, truncation. There's a bunch of different ways you can do it. But this shouldn't be an issue in your regular environment because if you're storing it in a database, you're probably encrypting it or truncating it or hashing it. But look to see if the way that you're virtualizing, if there's a chance that things that are running in memory or perhaps a web server or a logging system might now be capturing credit card data and then storing that. This is probably one of the biggest risks in a virtual deployment that you want to ensure that you're not now increasing things that were just running in processing or transmitting and that now you're copying that into a storage area. So particularly as an assessor, we're interested in like encryption keys. So if you are now capturing an entire server, that server has storage and it also has the encryption keys also in that image, and you're moving that to a SAN, and you're saying your SAN is not part of the PCI scope, there's a lot of risk there. So those are some areas, in particular, encryption keys and data storage, you want to make sure that you're documenting well. So 4 is going to be encrypting transmission of cardholder data across open public networks. So this shouldn't be an issue for most organizations unless you're really large and you've got a large WAN or metropolitan LAN going out, because open public networks, usually you guys are going to be dealing with some fiber connections, some IP connections, and it's not going to be considered open public. So one of the things here, which obviously security folks don't want, but the community is moving towards, is PCI only requires that you encrypt data across public networks. You can send unencrypted data internally, and it's fine. So if you have a web server and it transmits unencrypted data to a database server internally, that's OK. You can be compliant. It's obviously not recommended, and there's some other things that you can do. But PCI can't come out and tell everyone they have to encrypt all data internally because that's just a very huge burden for the community. So just think about that. If you are transmitting over open public networks, this also includes Wi-Fi, some of the cellular networks, and satellite connections. So depending on what those are, if you look at the requirement, PCIs define what they say is open public network, and look if you've got a large virtual infrastructure on whether you're now sending data unencrypted or sending an image unencrypted over an open public network. 5, antivirus programs. This was more of an issue a couple years ago. Now there's a lot of different products that can help address this, but you want to make sure any component you have that's commonly affected by viruses is patched. And so when you look at it, I would say ESX is not a system that right now is generally considered to be commonly affected by antiviruses. This isn't just a Windows systems, though. So they've got a lot of different components that you have out there. So if you're going to define which systems have antivirus and what your process is, you want to make sure that all the virtual solutions out there are going to have them. And so that's going to go into some of the hardening documents that you guys are building, the way that you guys are designing the configuration. But you want to make sure as an assessor, if they're going on and they're sampling 20 servers and 3 of them don't have antivirus because the way that they were provisioned and brought into the system, they just didn't have it. Or you guys are using an older version of Symantec that was built 3 months ago, and when these versions got deployed, they're 3 months old and they didn't get updated. So there's some unique challenges in there, which now there's a lot of other technology to address this. 6, so this is probably one of the most critical sections in a virtual or a cloud environment. And so when I look at this is developing and maintaining secure systems and applications. Because the way that virtualization works, it's kind of a hybrid of both. Right? It is systems, like we traditionally think of, and it's also applications. So it's important that the process for creating, implementing, maintaining the virtual environment or cloud environment or anything you're going to do is very difficult or different from the physical environment. So how you guys deal with things, disaster recovery, business continuity, all of those areas, that really needs to be addressed. And if you look at it, PCI doesn't have a section on business continuity. So if your systems aren't running, they're secure, right? If you can't access them, an attacker can't access them. But most people that are doing virtualization, right, PCI or compliance is a component, but you're also doing it for availability, business continuity, some of those other areas. So you just want to make sure that those other processes that may have been excluded in your physical environment may now be brought back in based on your virtual architecture. 7 is restricting access to cardholder data by business need to know. And this is a particularly challenging area in the virtualization environment because in small organizations. So if you're a small organization, you have 3 or 4 or 5 administrators or super users that are going to be administrating the virtual environment, they have control to the hypervisor level, which means they have control kind of to everything else in those systems. So this is an area where you're really going to have to document how you guys are restricting access to business need to know. And if there is a business justification because you only have 4 people or 2 people and they both need to share that data, that's okay. Just document and make sure there's a business reason there. And the other part of virtualization is there's going to be several role-based access controls in place. Right? You're going to have access to the hypervisor. If you have a jump server, that may be going through another RAS server. You may have the virtual components you have with Active Directory. You may have individual standalone servers that are running Linux, Red Hat, whatever you have. So document all the role-based access controls you have. Think about the firewalls, the routers, and the servers, not just the primary way that people are doing things from their desktop. 8 and 9 really shouldn't be too much difficult. So 8 and 9 are kind of some of the freebies for requirements in that they don't change in a virtual environment. Every action has to be traced back to an individual, so there can't be shared logins. And 9 is physical access to the cardholder data. So these physical environments still need to be protected. But again, make sure you're considering your disaster recovery site and what you're doing with those locations. So there's just kind of 3 more requirements here. 10 is going to be tracking and monitoring access to network resources. So this is another area where there's several different ways of meeting this requirement based on a lot of the different solutions out there. So VMware and a lot of other third-party products have implemented things to make sure that the logging and level of detail is there. And if you just look at it from a common sense perspective, PCI has a lot of requirements, but this is what they're really trying to get at. Is they're trying to say, if there is an incident or a suspected incident, how would you know? And if something does happen, what sort of logs do you have to guarantee that only so much data was accessed or only so many systems were accessed? And so this is kind of, it's a good thing if you're doing it well. Because let's say you have your website's defaced or you have a SQL injection attack and someone has access to that server. PCI is going to require that you notify certain people. Different state laws are going to require that you notify people as well. And so then the burden goes back kind of to IT and compliance to say, well, what was accessed? Well, if you only know that hacker X accessed this system at 9:32 and you noticed it at 11 o'clock, he had access for an hour and a half, but you have no idea what he accessed, you're going to be putting yourselves in a tough situation. And you're going to work with your legal counsel to say, well, does this count as a breach? Do we have to notify everyone? And so the logging then will allow you to say, yes, this person had access, but they had no idea this was a credit card data system. And they were just trying to deface our website and put up some political statement, but all the credit card data was protected, no one had access to it, and if it was, we would have logged it. So this also helps provide protection in the event of an incident or suspected incident to make sure that you're not running around and making notifications you don't have to. So PCI has a lot of log requirements, and some of the virtual components don't have the same robust logging requirements of their physical components. So when you look at like the virtual firewalls, a regular firewall now will have some very good logging. When those get virtualized, if you guys are considering them part of the PCE, you want to make sure that you understand how those firewalls are logging, what they're doing, and if they can't, that then you guys are mitigating that risk by other controls that are in place. The other critical area I want to have on here, which is really an architectural thing, is if you're logging the ESX server, logging access to the hypervisor, those logs can't be stored on a virtual appliance that's residing on the same servers, right? This would be akin to you storing your keys in the window of your house and saying it's protected because it's inside of your house and no one can get inside of your house without the keys. You have to make sure that those logs are sent to a central location and that if you compromise the hypervisor or if something were to happen or if there was a zero-day attack, those logs are going to be secured. And that's going to help address some of the other areas that we have there as well. So the logs need to be secured and they need to be forensically sound, meaning they can't be altered. And you can't say that they're forensically sound generally if they're going to be stored on the same systems that they're logging. 11 deals with mostly pen testing and vulnerability scanning. And so when you look at what is being scanned, one of the unique challenges in a virtual environment is you may know that you have 100 servers in your physical environment, but at any given day in your virtual environment, you may have 90, you may have 200, it may vary. And so this is something that the data security standard really doesn't address because it requires that all external systems be scanned, but those systems could vary. And so this kind of goes back into kind of the configuration that you're building is if you've got a consistent configuration and all of your web servers are built the same, I would think that most of your assessors would say, well, if you scanned everything that's publicly available and there was no issues with them, then it shouldn't be an issue with, if those scale out or scale down. And one of the things that I use for is, vulnerabilities only come from two areas. They come from software issues or configuration issues. So if you configure things correctly and you can demonstrate the software's there, the scanning really shouldn't be an issue. So the last requirement is maintaining a policy that addresses all these areas. And so there's a lot of documentation that I mentioned here. I mentioned page 6, which is an area that you really want to define. And keep updated with what's happening with the PCI standard. So the new standard will get published here in about a month or two. There's different people have different access to the drafts. They have different special interest groups that are going out. So if you're not on these teams, if you're a participating organization or QSA, you can get on these to kind of see what's going on. You're bound by some of the NDA things to not share the secrets before they come out. But they'll be out sooner or later. And so once those are out, you want to make sure that you're interpreting that, and particularly what's not there. So the data security standard is not going to address a lot of areas that you want to address. And the special interest group is not going to address a lot of the areas that you want. So in absence of that, you have to work to say what is reasonable from a security and audit perspective in absence of this guidance in our environment. Because it's just if you just keep waiting, it'll never happen. So with that, Charo, I'll turn this back over to you to kind of close out, and then we'll stick around here if you have any questions.
All right, so that's pretty much it. If you want to learn some more information, go to the URLs you see on the screen here. We're continually trying to get more and more guidance out there. I think when the new standard comes out, we'll be able to kind of help you interpret that and how it will apply for your virtual environment. And so we'll be putting more stuff out there on these websites that you see here. Okay, we'll be happy to take questions now.
If you don't want to share your dirty laundry with everyone, we can stick around also.
Yeah, we can stick around here as well.
All right. Well, I think we're good. Well, thanks for your guys' time. Appreciate it.
Thank you.